We are standing today at the center of a monumental industrial earthquake that is shaking the foundations of global technology. For 40 years, exactly one company on earth has maintained an absolute monopoly over the light lithography machine required to build every advanced computer chip. When the United States pressured that sole Dutch manufacturer to cut off China, the Western assumption was simple: China's chip industry would stall forever. Yes, inside a secret Chinese laboratory, a desktop sized device utilized a method that the original manufacturer had tested, rejected, and thrown away decades ago. Using this discarded technique, they successfully etched a working real world 14 nanometer chip, proving that physical principles cannot be permanently locked away. This was no theoretical paper or computer simulation, but a tangible physical proof of concept that rewrites the geopolitical rules of hardware manufacturing. To truly grasp the magnitude of this breakthrough, we must look at why the lithography machine sits at the very heart of modern civilization. Every advanced smartphone, server, and artificial intelligence model begins its life as a blank silicon wafer etched with billions of microscopic transistors. Traditional ultraviolet light hit its physical wavelength limits as circuits shrank down to fractions of a nanometer, forcing the industry to adopt extreme ultraviolet light. Generating EUV light requires firing powerful lasers at microscopic tin droplets inside a near-perfect vacuum at 50,000 times per second. Building this marvel took decades of global research and tens of billions of dollars, leaving ASML as the sole, undisputed monarch of the semiconductor universe. A single EUV machine costs $200 million, weighs as much as a jumbo jet, and remains utterly irreplaceable on the open market. When export controls locked China out of this supply chain, Western planners assumed China had it an impenetrable wall. However, scientific papers are not classified wallet secrets, and China possessed a secret weapon. Lin Nan, a former ASML light source researcher, while ASML had long ago abandoned solid-state laser generation as inefficient, Lin Nan's team at the Shanghai Institute picked up that exact discarded road by systematically refining the solid-state approach. They achieved incredible conversion efficiencies, matching and exceeding historical European research benchmarks. Simultaneously, a secretive team in Shenzhen, dubbed China's Manhattan Project and featuring former ASML engineers, began building a full-scale domestic prototype using salvaged machine parts. secondary market components, and export restricted hardware. The pieced together a working optical and light generation system, although high volume factory production and ultra pure photoresist chemistry still present massive hurdles. The 14 nanometer breakthrough proves the concept works as China's domestic equipment self-sufficiency climbs past 35%. History shows that technological containment often acts as the ultimate innovation accelerant. In our next exclusive episode, we will uncover the deep economic ripples of this hardware war and what it means for global supply chains. Make sure to subscribe to the channel, hit the notification bell, and share this deep dive with your engineering network. Join the frontier of AI revolution.